Any sort of movement requires energy. This is the ways in which the body creates energy are determined by the length and exertion level of the activity that someone does. Anything that requires short, sharp bursts of energy, like sprinting, needs the body to use large amounts of energy in a very short amount of time, while sports such as endurance cycling require continual energy production over a large period of time at a slow rate. It is the energy systems of your body that facilitate these processes. The body's ability to get energy via food and take it over to the contractile proteins in the muscles. This is what decides a person's capacity to exercise at different intensities and for different amounts of time. The body maintains a supply of energy via the use of ATP, molecules that contain and release chemical energy for use in body cells. ATP is made from adenine and 3 different phosphate groups. It is made in the reaction amongst adenine diphosphate, ADP, and a phosphate. ATP is a strong molecule that is used for many things. The energy is stored in chemical bonds found in the molecules. When this connects itself with another phosphate, the energy is then stored so it can be released later. When ATP is mixed with water, the last group will be split off and energy released. The body's energy systems can function either anaerobically or aerobically. Energy is needed to allow the muscle fibers to contract, which is gained via the oxidization of foods, in particular carbohydrates, which are broken down into glucose. If it isn't required by the body straight away, it is turned into glycogen, which is stored in the liver and muscles. Fats, broken down to form free fatty acids. These will eventually be burned in the muscle cells. This is when ATP is formed. When this is broken down, it gives muscles energy, which are needed for contractions. Only the molecule is used to supply the muscle fibers with energy. It is done in 3 ways: the creatine phosphate energy system, the lactic acid energy system, and the aerobic energy system. We'll now explain the ATP-pc system. ATP and phosphocreatine together make the ATP-pc system. This is also known as the phosphagen system, which is the first energy system the body will use when energy is needed. Creatine phosphate is a high energy compound. When exercising, energy needs are immediate, so the PCR stores in the muscles are used to provide the energy which comes from the splitting of the link between the second and third phosphate molecule in ATP. When the energy from the PCR system is dismantled, the energy it releases is used to fuel muscular contractions. PCR is the phosphocreatine system, which is also known as the ATP system. But the muscle's own stores only contain enough ATP for 2 to 3 seconds of contractions, after which it must be resynthesized. This happens even when the body is still exercising. The reaction that creates ATP in the ATP-pc system is ADP plus creatine phosphate, which gives ATP plus creatine. This system is used to produce ATP to fuel up to 10 seconds of high-intensity muscular contractions. Every activity depends on the phosphate system. For example, some examples are shot put, discus and jumping events, which all require short, intense muscular contractions. Phosphocreatine hydrolysis does not rely on the available water. The phosphate system is important because of the extremely rapid rate it is able to regenerate ATP. When doing intense exercise, the energy gained from the phosphate system is used for around 10 seconds until the body's stores of C-reactive protein are mostly gone. The system's energy capacity relies on the amount of creatine phosphate available to it. Many sports like football require more than one repeated period of demanding exercise, which have gaps of either passive or active recovery. In football, it is mainly passive, which means the speed of creatine phosphate recovery kinetics also must be understood to know the role of the phosphate system in sports. An athlete's ability to recover their CPR stores over and over again so they may produce maximal energy outputs have a massive effect on the athlete's performance. If they cannot replenish their stores quickly or efficiently enough, performance is affected and the prize they are competing for may be lost. We'll now discuss the advantages and disadvantages of the ATP-pc system. They are as follows. The advantages are very quick release of energy so the ATP may be resynthesized. This is a continuous system. ATP is broken then resynthesized, which is done continually in the body after stores in the muscles are used up. No harmful waste products are produced in the reaction that splits and creates ATP, meaning the muscles should be able to work longer and more efficiently because the pH of the muscles shouldn't change for a longer period of time. Can produce maximum speed of the body whenever it is needed, for example in a sprint race. Its recovery time is 2 to 3 minutes with the presence of oxygen, which is fast enough for a sport like football, so players are still able to play well. The process is not catabolic as it doesn't use glycolysis. The catabolic process is a destructive metabolism which releases energy. The system can be trained to become more efficient, meaning it can go on for longer, which is advantageous in sports like sprinting, as it means they can continue at a higher pace for longer, meaning they may get a higher finishing position. The way it is trained is through the work-to-rest ratio. For the ATP-pc system, this would be 1 to 10 over 12. This means for each second of work, the body must be allowed 10 to 12 seconds of rest. For example, if they worked for 1 minute, they need to be allowed 600 to 720 seconds of rest. This system uses fast twitch fibers to allow for intense short contractions. The reactions needed to synthesize ATP is the simplest of the 3 energy systems, allowing it to generate large amounts of ATP quickly. The disadvantages are a very limited supply of PC stored in the muscles, as there is only enough for around 10 seconds at maximum intensity, which is disadvantageous in sports like rugby. When a player runs for the touch line, it will often take more than 8 seconds. meaning they will have to switch energy systems over to the lactic acid energy system, so maybe will be slower and may be caught. Restoration of PC can only occur with the presence of oxygen and will take up to 3 minutes. This is disadvantageous as it is too long for certain sports like marathon races. It will take too much time to replenish the stores and they will lose their place and possibly the race. Only one molecule of ATP can be resynthesized per molecule of PC. This system is used in different sports such as archery. The PCR system is used in this sport when the archer pulls the string on the bow back, so it requires a short intense burst of energy. Basketball. The PCR system is used in this sport when an attacking player throws the ball into the opposition's hoop, which requires the player to push and throw the ball with one push of a high intensity force. Netball. The PCR system is used in this sport when a defending player jumps up in the air to block the attacker's throw, which requires maximal effort for the defender to launch themselves high enough in the air to block the ball. Football. The PCR system is used in this sport when taking a penalty, as the attacker kicks the ball with the maximum effort they can and put into one kick, so this system is used to power contractions in the legs. Hockey. The PCR system is used in this sport when an attacking player strikes the ball towards the defender goal, which requires one high intensity contraction. The ATP generated is used to allow contractions in the arms and abdominal muscles.